Motorsports. As its name suggests, is a form of sport involving the use of motor vehicles instead of a ball or a puck, with teams, drivers, and categories competing all across the world for various titles. These cars are designed to the nth degree with every element optimized, with the key example being the aerodynamic devices and body panels upon the car, which are commonly constructed using carbon fiber reinforced polymers. These composite materials provide incredible strength at an incredibly low weight, with intricately molded and sculpted pieces being a common fixture across motorsport cars, and I've been lucky enough to have first-hand experience with them, getting to know the manufacturing processes, the safety precautions, and the disposal methods. To put it bluntly, these materials are a nightmare to recycle. During the manufacturing process, any excess resin or scrap pieces of carbon become waste into a landfill bin, and during the event of a crash, these pieces are usually so thin or designed to shatter that they just break into a million little pieces. These large chunks can be collected by marshals at the side of a circuit, but there are usually millions of pieces of carbon smaller than a grain of rice, which are left to leach into the soil and gravel and the surrounds of the circuits across the world. This pollution via debris is kind of a given in motorsport. These leagues aren't really doing much to address it, and everyone's kind of just like, yep, this is a part of what happens. Motorsport circuits are dirty, toxic places. And that was really the kickoff point for this project. How can I create something that performs in a similar method to a carbon fiber reinforced polymer in terms of its stiffness and its strength, whilst providing a materials wastage loop closed solution for manufacturers that are usually manufacturing the same design for like spec cars, for an example, in a volume of 1,000 or less per year. This recipe involves a blended combination of traditional composite and biodegradable plastic manufacturing techniques. Hessian fabric has been used as a woven fibre of choice, with a waste cycle built into industry such as the coffee bean industry. Suppliers are even selling their bags to give them second lives. Gelatin has been used as the binder here, as it's shown good strength and absorption during the testing processes. Now, to make this, you'll need some sort of mold to lay your piece into. For flat pieces such as a strake or an end plate, something flat like a baking tray works well. For curved pieces and aerofoils, more complex molds are needed, such as this one are made from a UHT milk carton and some tape. Now firstly, cut out the Hessian into the layers and sizes needed for your piece. I recommend at least 2 for enough rigidity. Then mix your plastic together using this ratio of gelatin powder, glycerin, and warm but not boiling water. You will need to adjust the volume to the size of your molded piece, and make sure to give it a good mix and get any lumps out here, as these will travel into the final product if you don't get them out now. From here, pour or soak your Hessian pieces into the plastic mix, ensuring that all of the needed parts of the Hessian are coated in it. It's a good practice to leave a little excess at the edges of the pieces to allow for any of the excess plastic mix to soak into the excess fabric rather than pooling in the mold and creating an uneven thickness. From here, it's a waiting game. Let your molds chill in the fridge for at least an hour, but ideally overnight, and then they should be pliable enough to remove from their molds. Trimming of major excess pieces can be done at this stage, but I'd leave the final cut until it's fully dry in case of minor warping. Once fully dry, the pieces can be adhered together using your choice of adhesive or attachment. Here I've chosen to use a Casonate binder. So this is the finished product here. I fashioned it into a little rear wing. It's probably about like a quarter or fifth scale of what you find on a GT car in real life. Now, it's not as like performative and strong as a full-on carbon fiber piece you'd see on a real race car, but if this was to be like snapped in half and thrown on the ground or thrown into some dirt, it would compost, it would biodegrade and not like poison and leach into the soil like a plastic would. And that's really what I wanted out of this, to kind of open that conversation around this wastage and pollution problems occurring at motorsport circuits across the world. Thank you for watching.